right, let's walk through the fourth and final stack of this particular code demonstration. So we're paying attention to the stack on the left. I've listed both the dashboard stack and the web API, the WebSocket API stack, just for context. So the dashboard stack simply deploys an S3 bucket and then utilizes the bucket deployment construct. So the S3 bucket itself is going to be configured as a static website hosting bucket, and then the bucket deployment construct is an L3 construct, which is used to copy files, any files really, to an S3 bucket from one's deployment machine. So the deployed resources here are going to be obviously an S3 bucket, and then the bucket deployment construct itself actually utilizes a lambda function to shuttle or shuffle the files that you want to target for your S3 bucket from the intermediary S3 bucket where all resources get staged at when you use the CDK, and then moved into the static website S3 bucket. And again, I just think for context, it's useful to see how these two stacks work with each other, or particularly the React dashboard website that is going to be interacting with the WebSocket API gateway. So someone will make an HTTP GET request to the S3 bucket static website URL, and that's going to pass down the React-based dashboard application and load up in a user's browser. Upon loading that, it's actually going to fish out a query string parameter that should be supplied to the website URL that represents the API gateway WebSocket endpoint. So it'll use that URL to establish a connection to the WebSocket API gateway route, and then after that happens, it can start receiving the real-time update data pushes from the broadcast lambda function, pushing revenue data back down via the two-way communication protocol of the WebSocket API down to the React app. So we get real-time dashboard updates and a couple of different simple charts that we're going to look at. All right, so let's go ahead and dig into the code then. I'm going to go ahead and close. Let me close everything except for this guy. And we'll see that the very last stack here is the dashboard stack. And the dashboard stack expects to get the env object that was given to all the other stacks. It is called the dashboard stack by name. And then it is given the WebSocket API URL that was defined in the WebSocket API stack as described in the last video. All right, so popping open the dashboard stack, no new imports this time. We import the same stack props in CloudFormation output, as well as the construct class. However, we do import the S3 package from the S3 module, as well as the S3 deploy module from AWS S3 deployment module. And then we'll utilize path again because we're going to source files from the local file system, and that makes that a lot easier. The stack props for this particular stack, we already saw, expects to get the WebSocket API URL passed to it. And the definition of the stack, once again, it is a stack, so it'll extend from the base stack construct. The scope, as always, for a stack is going to be the AWS CDK application itself. And then the standard props after that are the ID, the logical ID for this construct, and then the props that are defined right here. So inside of the constructor for this construct, we instantiate an instance of an S3 bucket, and we essentially turn it into a static website deployment by specifying the website index document as index.html. I also specify the website air document as just index as well. It's kind of common practice with today's modern SPA-based JavaScript applications to handle errors within the JavaScript application itself rather than have its own dedicated error page. So I usually just specify both of them as the standard index.html, and then handle errors within my React or Vue.js or Angular app or whatever it is. And then public read access to this bucket is necessary because obviously we want it to be available from any web client. And then last but not least, I specify a bucket deployment instance and then point it towards the sources, which is just my React.js app here instantiated and built out within the dashboard app directory, specifically within the build directory. And so that's going to take and it's going to copy everything that's in the build directory within here. So all of my statics, CSS, JavaScript, if there were images there, they would be there as well as all the other things in here, but the most important being the index.html. And then I guess I do create an CloudFormation output field, which is the static website buckets URL endpoint, and then a query string parameter of API URL that points to the Websocket API. So let's take a look at what's going on inside of the React app here. So this React app was just created with the standard create React app helper. And so within source, I have the app tsx component. And so I've utilized the charts.js and React charts.js libraries to simplify creating some charts. So I'll have a line chart as well as a bar chart. And define a couple of interfaces. So chart dataset, which is always just a label with charts.js, the data, which is an array of numbers, and then a background color for each one of my data points. And then chart data itself is composed of labels for the x-axis, and then data sets, which is just an array of this data sets chart data set interface right here. The customer aggregate revenue looks very similar, or actually is identical to the input customer revenue that was calculated in my stream processor Lambda function. And same thing with the revenue, the aggregate revenue as well, because after all, that is the input data that's fed through Kinesis. I've used the exact same random int function because I randomly generate the background colors for each one of my data points across the different customers. And I have defined my customers here again, just to simplify the setup of this. And so as my app component is instantiated, I create a chart state field for the line chart, and then a bar chart state field for the bar chart. I parse out the query string parameter pointing to my WebSocket API endpoint from the URL, and we'll see how that looks once we deploy it. And then that gives me an instance of a URL, and then I can use that to instantiate an instance of a WebSocket client. I subscribe my WebSocket to a message event, so add a event listener for any message event, so that as data is pushed from my Websocket API gateway down to this client. I can parse the data that comes through in JSON format. I will turn the window end time into a standard local time string, so that gives me hour, minute, and second. And then if, for whatever reason, I guess it's possible that duplicate data could be pushed down through. That happens sometimes with distributed systems. So if that is a new data point, then I go ahead and add it to my x-axis labels, and then iterate through each one of the customer revenues, adding them to their respective chart data sets, and then update the chart data sets using just like the standard use state setters from the React library itself. And then down here in my JSX area, I just create an enclosing div of class app. I think that's probably just carryover from the create React app boilerplate. And then I give it a title of customer revenue, and then I'm using Bulma for the CSS styling framework. So I'm creating a couple of Flexbox containers, one for the line chart and another for a bar chart. So that is the final construct, or the final construct stack, that is, for this particular code walkthrough. So in the next video, I'm actually going to deploy it, and we're going to see the end result running in my browser.